Good day, viewers. You are welcome. Let's see how we can solve these functional equations. The question is simple, but let's make it more simple. Here we have p of x over 4 multiplied by x over 4 equals 4 over x multiplied by 4 over x. And what is p of x? Now to solve this, when you consider from this domain of this function is given as x over 4 multiplied by x over 4. So when we see this, we have the multiplications between these two operations. We have the multiplication operation between these two variables, x over 4 and x over 4. When we multiply this together, we are going to have x times x raised to power 1 divided by 4 multiplied by 4. And by law of indices, we have this as x raised to power 1 plus 1 divided by 4 raised to power 1 plus 1. So having noted this, we have x raised to power of 2 divided by 4 raised to power of 2. And everything equals x raised to power 2 divided by 16. So this is what we have. Then, since we have simplified it to this term, we are going to have p of x squared over 16 equals 16 over x squared. Then to get p of x, suppose we let x raised to power 2 over 16 to be equals t. So by making this one to be t, then we are going to cross multiply and we have x squared equals 16 multiplied by t. So by taking the square root of both sides from this stage, so it's a big mistake, I'm going to leave this one as it is. So therefore I come back to the function, which is the p of, instead of x squared over 16, I'm going to write it as p of t. Or if you can't do that, instead of x squared that we make, we are going to change x squared to 16t divided by 16 equals, also we have 16 here divided by x squared becomes 16t. So 16 cancelled 16 and also 16 cancelled 16. We have p of t equals 1 divided by t. And let's change t to x, as we have p of x equals 1 divided by x, where x is greater than 0. So this is how we solve this. Thanks for watching. And if you say x greater than 0 only, does that define this very well? So negative also satisfy this. We can just say x is a member of a real number but not equals 0. So all positive number and negative number satisfied, but only when we have the 0 does not satisfy this. So thanks for watching. See you in the next video. Never stop learning. Bye bye.